All right, worksheet 4 kind of reviewed everything we've done so far. So the beginning piece was just making sure you remember how to evaluate logarithms. Common log, remember, was when there's a base of 10. Natural log is a base of e. So if you can tell yourself 10 raised to what power gives you 0.001, you move it 3 decimal places, so it's -3. If you aren't sure, put it in exponential form. So with all of these, like this was 1 over e to the 3rd, but the 5th root of that, so that's negative because it's in the bottom. So it's e raised to the -3/5 power. So the natural log of that is -3/5. If they get a little bit tougher, like either 4 or 5, I actually set it equal to x and put it in exponential form to help me out. So like this one, radical 2 was 2 to the 1/2. So 2 to the 1/2 raised to the x equals 8, which is 2 to the 3rd, and then I can see that 1/2 x equals 3. Same with 5. I said 4 to the x equals 8 radical 2, so I put 4 in it as a base of 2, that's 2 squared. 8 is 2 to the 3rd. Square root of 2 is 2 to the 1/2, so when I add these two together, because when you're multiplying like bases, you add the exponents, I got 7/2. So the 2x over here has to equal 7/2, and then I solved to get 7/4. 6 is similar to the other one we had on one of the last worksheets. If you aren't sure, set it equal to x. You have two logarithms here with the same base, so when you put them together, since it's a sum, it's 7 to the log base 7 of 18. So you either can know that's 18 right away, or set it equal to x. And then put it in log form. Log base 7 of x has to equal your exponent. And again, that's always then going to come out. As long as the base of the exponent and the base of the log are the same, then you always know that that number is going to be 18, whatever you're taking the log of. So just make sure that, if you aren't sure what it is, again, set it equal to x and then go through the process. 7 and 8 are, again, the expanding ones. Just remember, anything that's in the numerator should be a positive. Anything in the denominator should be a negative. Make sure you remember that when you have radicals, think of those as powers. So this is y to the 1/5 power. And then anything that is a power, remember you have to use the power property and bring it out front. So that's why this is 3 times x, log of x, instead of log of x to the cube, or x to the 3rd. And this one's 1/5 instead of the 5th root of. Same with this one. And again, what we did the last time is we said, let's just rewrite this as 5 to the 1/2, y to the 9/2, x to the 9/2, sorry, and then y to the, if you have 1/3 raised to the 1/2, that's going to be y to the 1/6. A power to a power, you multiply the exponents. Then it's easier to expand it out to get 1/2 log 5 and 9/2 log x and so on. Okay? All right, the graphing ones. I had a few questions on graphing, especially when it was the natural log. Realize natural log and common log and log base 3, they all have the same parent function. Vertical asymptote at 0, it's an increasing graph, and it goes through at 1, 0. So what happens with this one? Well, don't forget you have to factor that negative out before you can decide what happens. So when I take the -1 out of those two terms, I see that it goes 2 to the right because of the -2, so I draw in my vertical asymptote at 2. The only other thing that happens is the x is getting reflected, so it's reflecting over the y-axis. And so now instead of the shape looking like this, it's going to be reflected looking like this shape. Nothing is stretched, so I'm still going to go 1 unit over. So if this is my vertical asymptote, I go 1 unit over to get to my intercept, and then I graph it. With the second one, number 10, now the negative is outside of the log, which means now instead of reflecting over the y, it's going to reflect over the x. So now it's going to have that shape because it's reflecting over the x-axis. This one, the x's are getting stretched by 5, so instead of going 1 unit from the vertical asymptote, I have to go 5 units from the vertical asymptote. So that's why it's at 5, 0. So it got reflected over the x, and it got stretched by 5. Okay, then on the back, all through 18 is all log equations and exponential equations. So remember, 2 kinds of equations. This one already is in log form, so just put it in exponential form. when you have a base like this raised to a power, raise it to the reciprocal power so that you get x to the first power. And so I had to do the same thing over here. The negative means that it's going to go into the denominator, and it's 1/3, so the cubed root of 64 is 4. Another kind of log equation you have is if you have two logarithms with a number, and so you first have to use your properties of logarithms, so it's the log of their product. Once you get a log equaling a number, put it in exponential form. 6 to the first equals that. I factored it, it's quadratic. The -6 doesn't work when I plug it in, but even though x is -1, when I plug it back in up here, I'm going to be taking the log of a positive. So don't just cross it off if it's negative, cross it off if you plug it back in and you're trying to take the log of a negative. That's when you get an out of or domain problem. 13 is an exponential, so just put it in log form. Log base e, so natural log of 5 equals 1 minus x, and you solve it. 14 is an exponential equation, and if you should notice that all of these can be put into the same base. So 2 to the third, 2 squared, and that one already was a 2. When you're multiplying like bases, you add the exponents. So when I add these together, 2 to that power has to equal 2 to the third, so my exponents are equal. Again, it's a quadratic, and I solve the quadratic. This one's a log equation, 15. It's a log equation, and it equals a number, so we put it in exponential. Now, the square root of 2 raised to the -6 is a little tricky. So always think of radicals as exponents. So square root of 2 is 2 to the 1/2. Then I'm going to raise it to the -6. So when a power to a power we multiply, that gives me 2 to the -3rd. So always be thinking to put your radicals as exponents, then use your property of exponents. And then to solve for x, I got x is -39/8. Again, if I plug that back in, and I take -39/8 plus 40/8, I'm still going to be taking the log of a positive. 16 is two logarithms that are equal to each other, but there is this 2 out here, so you got to take care of that 2 first. So you bring it up as a power. Now that you have the log, common log of one thing equals the common log of another, now you know those two things are equal. You set them equal, quadratic, factor it. Both of those, when you plug them back in to the original problem, you will get a positive. 17 again has two logarithms and a number, so we have to use our properties of logs over here. So we have to take the -2, bring it up as a power, so that becomes x to the positive second power. Again, think of the square root of x as x to the 1/2. So if you're adding two logarithms, you write it as the log of their product. And now we do it in exponential. 3 to the 16th has to equal x to the 5/2. Raise it to the reciprocal power. And when you take a power to a power, you're multiplying, so I get 3 to the 32/5. And then 18, just put it in exponential. 3 squared equals the square root of x minus 2. And then to undo that, you have to square both sides and add 2. And again, you plug that back in and you're fine. It works. All right, and then the last two I'm going to spend a little bit more time on is the exponential. You need to realize both of these are an exponential. I did tell you that you're supposed to put that to equal 0. So the easiest thing probably for you to do is pick that middle term to be u. So u equals e to the x. Over here, u equals 2 to the x. And then you need to decide what u squared is. So if I square both sides of this equation, I get u squared equals e to the 2x. And that's what I have right here. So that's u squared minus 5u plus 4. Now, factor that, solve for u. Once you know what u is, replace it again with your e to the x, because don't forget, u is e to the x. So you get e to the x equals 4, put it in log form. E to the x equals 1, well, e to the 0 equals 1, so there's my two answers of that one. This one was a little trickier because you had this 2x plus 1, but again, if you know that e to the 2x is u, you have to look at this 2x and say, how do I get 2x plus 1? Well, that's 2 to the first times 2 to the 2x. That would be 2 to the 2x plus 1. So now I have 2u squared minus u minus 3 equals 0. And now I can go through and solve again just like I did before. Once I have u, I replace it with what u equals in this problem is 2 to the x. I use my log form. On this one, 2 to the x can never equal a negative, so I cross that one off. So think about what u is, that middle term. Decide what happens when you square both sides, and if there's other things here, you're going to have to decide how to break it up so that you can put things in terms of u.